We are Team NLPunks, and we are presenting a paper called Cross-Lingual Transfer of Debiasing and Detoxification in Multilingual Language. So before we start presenting, I would quickly like to introduce our team. Now back to the point, why this study matters. So as we know, nowadays LLM power global applications from chatbot to a search engine, virtual assistants, and nowadays even government use them. But there are several studies which shows that this model produce more bias and toxic output in non-English languages. But most of the mitigation technique that we use to reduce bias and toxicity are developed and tested in English only. This create a major gap which this paper try to address. So why test cross-lingual transfer? So there are three major reasons why author try to test this. First is practicality. We cannot create curated data for all applications and is costly and time consuming. Secondly, potential efficiency. If transfer is successful, then we can provide English fixes and it can propagate to other languages. And third is risk involved. If transfer fail and we don't have countermeasure, then non-English speaker continue to face a toxic and biased content. And they why what they ask and how they test it. So central question of this paper is, does English only debiasing and detoxification transfer efficiently to other languages or not? To test this, author used two approaches. First is SFT, supervised fine tuning, in which use curated data, and other is direct difference optimization, which use direct differences by human beings, which is tested over 20 languages and 7 LLMs while measuring safety and generation quality. So this paper not only tests whether the trade-off is possible or not, but also the trade-off that comes with it. Next point will be explained by Akhil.
All right. Now coming to the related work part, we will see in the slide what past work has been done regarding this paper. Okay. So before this paper, the prior work mainly focused on debiasing but embeddings and masked language models, for example, like BERT. Some methods like ADEL were also introduced in those papers, and those have shown transferability to 6 other languages. Also, it was mentioned that small data sets for debiasing leads to catastrophic forgetting. And English only fine tuning can damage cross-lingual performance. Now, coming to the detoxification part, previous studies explored that we can mitigate the toxicity in cross-lingual transfer and DPO for toxicity mitigation transfer from English to other language, and how this is related to bilingual sentence similarity. Also, some papers showed impact on debiasing and detoxification, and they also showed that debiasing hurts fluency and detoxification increases loss. Now we will come to the part why this paper is different from these previous papers. So instead of working on just word embeddings, this paper fully focuses on multilingual LLMs, and it also checks for cross-lingual debiasing and its effect on model performance and what are the features that are important for the cross-lingual debiasing. But then this also focuses on debiasing versus detoxification trade-offs, not for English but for multiple languages as well. Also, to mitigate that catastrophic forgetting part, it uses large language dataset, and it also compares SFT and DPO across languages. And other predictive factors was also discussed in paper and how they are better than bilingual sentence similarity. That's it. Now, next part will be explained by Ayush.
Next, my topic is methodology. So the researchers used these 7 LLM models, and all of them have exposure to non-English languages. But IA23, IA Expense, and Llama 3.1 are explicitly trained in non-English languages. Next, so there are two fine-tuning methods they have used. Then the first one is supervised fine-tuning, and second is direct preference optimization, that is DPO. And they have used 4 data sets, 2 for debiasing and 2 for detoxification. And it is shown here. Next. So supervised fine-tuning. In this, we are giving 2 inputs. One pretend language model, and second is non-harmful text dataset. And After fine tuning, it will produce non-harmful completions, and its limitations are it may become too cautious because we are feeding too kind words, and we are um, removing all the mild and high toxic words. Second is, if the dataset has some predefined bias, then it will pass to the model. And if the third one is, if the dataset is not has not seen toxic cases, then the model will fail. Next. Second method is direct preference optimization. In this, dataset is given with prompt and harmful versus non-harmful completions, and after generalizing, that means after fine tuning, the model will maximize probability of non-harmful completions given prompt and minimize the probability of harmful completions per prompt. And the benefits are it's scalable because we just need one pair of harmful and non-harmful completions. Second is, it is very good for low resource languages like Gujarati, Hindi, Telugu, and all. Challenges are language specific toxicity may remain in, it may have Western culture spice. Okay, so the problem is to train large language models. Which has billions of parameters, it will need tons of GPU memory and GPU resources because we need to update all the parameters. So the researchers used Culora technique, and in this technique, they quantize the base model waste to for precision, and thus it will save the memory usages. Second is, they inserted LoRa adapters to the attention and MLP layers, and during training, the context based model is frozen, and LoRa adapters are updated at every training epoch. And after fine tuning, it will behave like fully fine tuned model, but it may have some 1 or 2% less accuracy as compared to the model in which we are updating all the parameters. Let me give you one example. If the dimension is 4096, then we will have around 16 million parameters. But when we use Culora, it turns out to be 65,000 only. In this, we are doing matrix multiplications. In that, we take two matrices. One is of n cross r, and second matrix is of order r cross n. By doing matrix multiplication, we will get full n cross n matrix. So in this, we will have to operate only 65,000 parameters. So in by doing this Culora technique, it will save the time and save the memory. Next. So benefits, as I told, massive memory saving, near fine tuning performance, and we need to train only 1 to 2% of the parameters. The next part will be told by Tirth.
Okay, so now coming to the evaluation, we would be evaluating two models, one before the fine tuning methods and one after the fine tuning methods. So overall, we are evaluating over 20 different languages on three key areas. First is bias. For bias, we are using Crow-Wise pairs, which is a bias datasets which is focused on race, gender, sexual orientation, religion, and other parameters. So, and the languages used on this are English, French, and Chinese like languages. In this, we are generating data set with two types of sentences. One that is stereotypical, and second is anti-stereotypical. The ideal score for this data set would be 50. uh, the second dataset that we are using for bias measurement are stereo set, which is uh, doing evaluation on parameters like gender, profession, race, and etc. And lastly, we are using MBBQ benchmark, which is basically Q&A benchmark for multilingual biasness. Next, we are assessing over toxicity. For that, we are using RTPLX, and it's an um, dataset which is used to evaluate the toxic generations of a model. Lastly, we are evaluating language ability. For that, we are focusing on four areas. First is language consistency. We are measuring language consistency by generating 1,000 sentences, 1,000 completions over each language. The fluency is measured by the uh, MD5 generations, like how much it is matching with that model. The diversity is calculated as the unique unigrams that are generated in the response which are not provided in the prompt. And lastly, for QA ability, we are using the global LMMU benchmarks. Next slide, please. So these are the evaluation datasets, evaluation results on various datasets, as you can see. Next slide. So there are two major findings. The first is there is no best method for the job. For debiasing, SFT on Panda dataset was the most effective as it reduced bias scores on multiple benchmarks. But coming to detoxification, DPO was the winner on the detox DPO dataset. In fact, SFT made actually toxicity worse in some cases. Next slide. And the second finding was the hidden cost of safety. The main trade-off was like when the safety improvements from English to other languages happened, the language ability of those models decreased significantly. The language confusion increased, and the other abilities like fluency and diversity of vocabulary in non-English languages also drastically dropped. Next, as you can see in the results, these are the data sets and the results from that. The next part of code architecture would be explained by Balbir.
Okay. So my part is to explain the how the code was implemented. The whole code base can be seen as like four layers, where this is the data processing layer, model training layer, evaluation pipeline, and analysis layer. So most of the work is being done in the model training layer, where the supervised fine tuning and the DPO training happens. And then all the data after the super fine tuning, we save it and then evaluate for the new checkpoints that we get after the supervised fine tuning and DPO training. Okay, so what happens in data processing layer? This subword overlap file, the subword overlap script basically analyze the token overlap between model tokenizers and close to 100 languages. And this process, Tatoba script just basically prepares the multilingual sentences pairs for evaluation. Can you please move to the next slide? Next slide. Okay, so in the training pipeline, you can separate out the whole training in the DPO and SFT separately, where the basically the data preparation, tokenization, initialization, and yes, using the QLoRa, we just initialize the model for the memory efficient training. There are some hyperparameters that was used in PEFT library that was like rank was used as 64 and the scaling factor was 16 and dropout was like 10%. Okay, next slide. And this is the evaluation pipeline which was observed.
Coming to the future work, these are the future work suggested by the authors. First one is long context evaluation. The models were not tested on long context datasets because of limited available datasets and GPUs. Second one is using better multilingual evaluation resources. Current evaluations depend heavily on English-centric tools like Perspective API, which may not generalize well to other languages. Third one is addressing catastrophic poverty. Safety fine-tuning in English alone often reduces general language abilities like fluency, diversity, and consistency in non-English languages. Fourth one is combination of techniques. Combining supervised fine-tuning and direct preference optimization and other alignment methods such as constitutional AI or using language-specific adapters for better multilingual bias and toxicity reduction. Next part will be explained by Vandan.
As my teammate said, the long context evaluation was not done in this paper. So in long context evaluation, toxicity or bias often emerges when a long context is given, when a long context for the prompt is given. So how can we approach this solution? To approach this solution, the long context data set can be prepared with synthetic toxic dialogues, and we can train this model with merging toxic and non-toxic examples. And to evaluate this model, we can use singleton training and multi-turn training. In singleton training, the toxicity sentence is directly given to us, and in multi-turn training, it involves dialogues. The second one is about the Indic languages. The second one is about the Indic languages, in which you can prepare synthetic bias DPO datasets, which is similar to the English bias DPO datasets, which has stereotype versus anti-stereotype completions from machine translation. We can train the data. We can train the models using this Indic bias DPO dataset. This training can be done per language bias DPS or cluster based. In per language bias DPO, we only train models on a say a particular language. In cluster based, we train models on a particular script on the script basis, such as Devanagari and Dravidian. The next is the experimental plan.
Okay, so the experimental plan for our project is, so one of the approaches we are trying is the toxic or biased neurons. So in this case, we are going to be identifying toxic neurons or biased neurons and we'll be suppressing them. So there are two particular methodologies we are interested in. One of them is asking LLM to identify toxic content. So where we pass toxic content and we are hoping the LLM would detoxify it or at least let us know this is toxic content, and in that toxic neurons would be activated. Another one would be giving detoxic content to the LLM and asking the LLM to toxify it. So in that case also the toxic neurons would activate and we would be taking a moving average of that and suppressing those averages, so, or those neurons. Next. Okay. The second option would be tuning specific layers for detox. So in this case, there is a paper that says that the specific layers or certain layers that are not important for inference in the sense that they do not significantly change the answers. And if we change those layers, it would not affect the model in negatively. So what our plan is that we would be using those layers to suppress the neurons which are responsible for passing on the toxicity. So yeah, and the third option is, next slide, please. Yeah. So the third option is using mixture of experts. So in this case, we will be creating multiple models, multiple experts, and we will be choosing those experts based on the need, right? So one of them could be debiased. We need a debiased answer. We need a detoxified answer, or maybe we do not need a debiased or detoxified answer. In the case like there is a factual or coding related task, those debiasing or detoxing might not be needed because those tasks may not have heavy amount of toxic or bias content. Okay. Next, I guess this is it. Thank you very much.